Somewhere out there, 24 billion kilometers from where you are sitting right now, a machine the size of a small car is drifting silently through the darkness between the stars. It has no AI, no self-repair systems, no upgrades. Its computer is older than most of your parents, and yet it is still alive, still talking to us, still sending data from a place no human has ever been. This is the story of Voyager 1, the most distant object humanity has ever built, a mission that was never supposed to last this long, and the engineers who refused to let it die. It all started with a coincidence in the early 1970s. Astronomers noticed something extraordinary, something that had not happened since Thomas Jefferson was alive. The giant planets of our solar system, Jupiter, Saturn, Uranus, Neptune, were slowly drifting into a rare alignment. This happens only once every 176 years. And for a brief window of time, it creates something remarkable, a natural highway through the solar system. If you launched a spacecraft at exactly the right angle, at exactly the right moment, it could use the gravity of each planet to slingshot itself to the next one. Faster and faster, farther and farther. No extra fuel needed, just pure physics. NASA scientists called it the Grand Tour. They realized that if they did not launch before 1977, they would have to wait until the year 2053 for another chance. So they built two spacecraft, Voyager 1 and Voyager 2. Expected lifespan? A few years, maybe 5. No one, not even the engineers who built it, imagined it would still be flying 50 years later. Before Voyager launched, someone at NASA asked a powerful question. If this spacecraft ever encounters another civilization, what should we say? Carl Sagan, the famous astronomer, led a small team to answer that question. They created something unlike anything ever sent into space, a gold-plated copper record, 12 inches wide, built to survive 1 billion years in the emptiness of space. On it, they placed the sounds of Earth. Rain falling, ocean waves, wind through trees, a mother's first words to her newborn child. Music, from Bach to Chuck Berry to classical Indian ragas. Greetings in 55 different human languages, and 116 images, sunsets, animals, mountains, humans of every culture on Earth. It is the most ambitious message humanity has ever sent, a love letter to the cosmos, an introduction from a young civilization still finding its place in the universe. Today, that record is drifting through interstellar space, 24 billion kilometers away, waiting, patient, for ears that may never come, or may. September 5th, 1977, Voyager 1 launches. The rocket punches through Earth's atmosphere and disappears into the black. Destination, Jupiter, 628 million kilometers away. 18 months later, it arrives, and what it found shocked everyone. Jupiter was not just a giant ball of gas floating quietly in space. It was a monster, a violent, churning electromagnetic beast. Radiation belts so powerful they would have killed a human in minutes. Storms larger than planet Earth itself, raging for hundreds of years without stopping. But the real shock came from one of Jupiter's moons, a tiny world called Io. Voyager's camera captured something that no scientist had predicted. Volcanoes, active, erupting volcanoes, blasting material hundreds of kilometers into space. The largest volcanic eruptions ever observed anywhere in the solar system. Until that moment, Earth was the only place in the universe where we had ever seen a volcanic eruption. Voyager changed that forever. Geology, the story of worlds, suddenly got much bigger. 1 year later, Saturn. Even from millions of kilometers away, the images were breathtaking. Rings, countless rings, not 2 or 3, thousands of intricate ringlets, each one shaped by invisible gravitational forces. But one moon demanded special attention, a moon called Titan. Titan is strange, beautifully, mysteriously strange. It has a thick atmosphere, denser than Earth's. Scientists believed it might harbor complex organic chemistry, maybe even the building blocks of life.
So mission controllers made a decision. They angled Voyager 1 for a closer flyby of Titan. It was a trade-off. By diving close to Titan, Voyager would use the moon's gravity to fling itself upward, out of the flat plane of the solar system. It would never visit Uranus or Neptune, but in exchange, it would begin a completely new journey, a journey out of our solar system entirely. It is 1990. Voyager 1 is nearly 6 billion kilometers from Earth. Its cameras should have been turned off. The planetary mission was long over. But Carl Sagan made one final request. Turn the camera around, just once. Take one last look at home. The photograph shows our entire planet as a single pale point of light, smaller than a pixel, floating in a vast, dark emptiness. Sagan called it the pale blue dot. Every king and conqueror who ever lived, every war ever fought, every dream ever dreamed, all of it on that dot. Sometimes the most powerful thing a spacecraft can do is show us where we came from. For decades, scientists had wondered about a boundary, the edge of the solar system, the point where our sun's influence finally gives way to the cold, ancient emptiness of interstellar space. They called it the heliopause, and no one had ever crossed it. In 2012, 35 years after launch, Voyager's instruments began sending back unusual readings. Particle density shifted, magnetic field directions changed, the solar wind went quiet.
Scientists studied the data for months before they were certain, and then they confirmed it. Voyager 1 had left the solar system. A human-made object had entered interstellar space for the first time in history. Beyond that boundary, the gas between the stars, ancient cosmic rays from supernova explosions millions of years old. And Voyager, small, aging, running low on power, was finally there, sending home data from a place no instrument had ever reached. Here is something most people do not think about. The hardest part of the Voyager mission is not getting there. It is keeping it running. Right now, Voyager 1 is over 24 billion kilometers away. When NASA sends a command, a simple instruction, it takes over 22 hours to arrive. Then another 22 hours for Voyager's response to reach us back. 2 full days just to ask a question and get an answer. And the spacecraft itself is ancient. Its computer was built in the early 1970s. Modern smartphones have more computing power than Voyager's entire system. Power is running out. Every year, the plutonium generator produces a little less electricity. Engineers have been turning off instruments one by one, like a doctor managing a patient with dwindling resources, carefully choosing what to keep alive, what must be sacrificed. And yet, through all of it, the signal keeps coming, faint beyond imagination. By the time it reaches Earth, it is billions of times weaker than the power of a single smartphone. But it arrives, and the giant antennas reach out across the void to catch it. Sometime in the late 2020s, or perhaps the early 2030s, the signal will stop. The power will finally fall below the threshold needed to transmit. And one day, the antennas will listen and hear nothing. But that will not be the end of the journey. Voyager 1 will continue drifting through the Milky Way for millions of years. No engine, no guidance, just inertia and gravity, the same forces that move the stars themselves. Still carrying the Golden Record, still carrying our music, our voices, our faces, a message in a bottle thrown into an ocean without shores. When Voyager launched in 1977, nobody alive today knew what a smartphone was. There was no internet, no GPS, no streaming video, and yet, with slide rules and sheer human determination, they built something that has outlasted everything it was designed with. Voyager 1 is not just a scientific achievement. It is proof of what happens when human beings refuse to accept limitations, when engineers spend their entire careers on a mission that started before they were born, when scientists stay curious long after others have moved on. Right now, as you watch this, Voyager is out there, moving at 61,000 kilometers per hour, sailing through the space between the stars, alone, but never forgotten. This was humanity's first step beyond the solar system, and it was taken by a machine the size of a car, built by people who dared to dream beyond their own lifetime.